All right, let's start talking about row reduction to echelon form. This says two matrices A and B are row equivalent if and only if B can be obtained from A using the following operations called row reduction. Now, in the first operation, row I can be interchanged with row J. So the first row reduction operation is that row I can be interchanged with row J. So that is, we can interchange rows. Now, row I can become C times row I. That is, we can multiply a row by a scalar quantity. So we're looking at the different row reduction operations, and operation one is that we can interchange rows. Operation two is that we can multiply rows by a scalar quantity. Now, operation three, row I becomes A row I plus B row J. That is, row I is a linear combination of row I and row J. A matrix is in row echelon form if the number of zeros before the first non-zero element in each row increases from row to row. So the number of zeros from the first, sorry, a matrix is in row echelon form if the number of zeros before the first non-zero element in each row increases from row to row. The leading diagonal consists of ones and all elements below the leading diagonal consist of zero. So below this, we have a matrix that is in row echelon form. So it says 1, A, B, 0, 1, C, 0, 0, 1 is a matrix in row echelon form. You'll observe the leading diagonal elements, they're all ones. All the elements below the leading diagonal elements are 0, and all the elements above it are non-zero or possibly non-zero. So example 41. Example 41 says row reduce the matrix A to echelon form. All right, so we need to get this matrix in echelon form, and we need to do it by row reduction. All right, so what's my first step? The first thing I'm going to do is that I'm going to make these two elements here and here. I'm going to make those two elements 0. Then I'm going to get this element to be 0. And then after that, then I'll convert. Then I'll get the leading diagonal elements to all become 1. So let's start and say that row 3 will become row 3 will become 2 times row 3 minus 3 times row 1. All right, so let's see what happens. 2 times row 3. If I multiply row 3 by 2, it's going to become 6, 2, 4. So that's row 3 when I multiply by 2. Row 1, I'm going to multiply by 3. So this is 6, 3 minus 3. Then I'm going to subtract. And so my row 3 is going to become 0, minus 1, 7. My new row 3 is going to be 0, minus 1, 7. Row 2, I'm going to multiply row 2 by 2, 2, row 2, and I'm going to minus row 1. If I multiply row 2 by 2, it's going to become 2, 2, 8, and I'm going to subtract row 1, which is 2, 1, minus 1. When I subtract, I'm going to get 0, 1, 9. All right. So all right, so let's turn the page. And when we do our new matrix, based on the steps I've taken so far, the matrix will reduce to row 1 remains the same, 2, 1, minus 1. Row 2 becomes 0, 1, 9, and row 3 becomes 0, minus 1, 7. All right, so the first thing I did is I row reduced the matrix so that the first elements in rows 2 and 3 are 0. Then I'm going to, now my new row 3 is going to become row 3 plus row 2. So now I'm going to have row 3 plus row 2. Row 3 is 0, 1, 0, minus 1, 7, plus row 2, which is 0, 1, 9, adding, and this is going to become 0, 0, 16. So this is 2, 1, minus 1, 0, 1, 9, and 0, 0, 16. So what I'm doing is I'm row reducing this matrix, the matrix A, to row echelon form. In row echelon form, the leading diagonal elements, right now, there are 2, 1, and 16. They're all going to become 1. All the elements below the leading diagonal, they're going to be zeros. All right, and then once I can get it in that form, it's going to be in row echelon form. So the next thing I need now to do is I need the first element in row 1 to be 1 and the last element of row 3 to be 1, and that is to get it in row echelon form. So row 1 is going to become a half of row 1, and row 3 is going to become 1/16 of row 3. So the new matrix is going to be 1, a half, minus a half. I multiplied all the elements of row 1 by a half. Row 2 is 0, 1, 9, and row 3 is 0, 0, 1. All right, so now my leading diagonal elements are all 1s. All the elements below the leading diagonal are 0. The matrix A has now been row reduced to echelon form. All right, let's have a go at example 42. Example 42 is asking us to reduce the matrix 3 with rows 3, 2, 4, 2, minus 1, 3, 4, 2, 2 to echelon form. All right, so again, I'm going to start out by making these two elements here. I'm going to start out by making those two elements 0. Then I'm going to make this element 0. Then I'm going to get the leading diagonals, the elements of the leading diagonal to all be positive 1. All right, so let's start out by saying that I'm going to get row 3 is going to become 3 times row 3 minus 4 times row 1. So 3 times row 3, that's going to give me 12, 6, 6. 4 times row 1, this is 12, 8, 16. That's 4 times row 1. All right, I want to be careful not to make any mistakes. All right, 3 4 is 12, 3 2 is 6, 3 2 is 6, 4 3 is 12, 4 2 is 8, 4 4 is 16. Then I'm going to subtract. When I subtract, I'm going to get 0, minus 2, minus 10. So that's my new row 3. Row 2 now. Row 2, I'm going to multiply row 2 by 3. So it's 3 row 2. And I'm going to subtract 2 times row 1. 3 row 2 is 3 2s 6. 3 1s 3. 3 2s 6. And 2 times row 1, 2 3s 6. 2 2s 4. 2 4s 8. And I'm going to subtract. When I do, I'm going to end up with 0, minus 7, minus 2. So based on what we have done so far, we should be at this point. Row 2 is 0, minus 7, minus 2. And this is 0, minus 2, and then minus 10. All right, I want to be especially careful not to make any mistakes. The next thing is we want to make that middle element in row 3 0. So let's multiply row 3 is going to become what? 7 times row 3 minus 2 times row 2. All right, 7 times row 3 would be 7 0 0, 7 2 is 14, 7 10 17. 2 times row 2 would be 0 minus 14 minus 4. Subtract, we're going to end up with 0, 0 minus 66. So right now we're at 3, 2, 4, 0 minus 7 minus 2, and 0, 0 minus 66. All right, so the rest is easy. I'm going to multiply row 1 by a third. So row 1, my new row 1 is 1/3 of row 1. I'm going to multiply row 2 by minus 1 over 7. And I'm going to multiply row 3 by minus 1 over 66. And what this will do is this will get the elements of the leading diagonal elements. The elements of the leading diagonal to all be positive 1. So this is going to become 1 2/3, 4 over 3, 0, 1, 2 over 7. So that's minus 2 times minus 1 over 7 becomes 2 over 7, and 0, 0, 1. All right. So what we've been practicing is we've been practicing we've been practicing row reduction, and what we have been doing is we have been reducing a matrix to row echelon form.